Hello everyone, this is Vijay Lakshmi Subnani from WinMaths YouTube channel. Here, WinMaths is a free YouTube channel helping students across Karnataka to excel in their PUC board exams and so many competitive exams. This channel helps to those who are studying PUC and guide you making a preparation for PUC as well as for various competitive exams. Okay, here in this session, I am going to take class on sets for first PUC mathematics. Sets is a first chapter for PUC first year students. Okay, here the chapter sets. Before going to take sets class here, basically we know the set. Okay, in generally set is a group. Okay, group of something, whatever. Okay, something means some values or else something, whatever it may be. Okay, numbers, objects, and so many things are there. Okay, why we study about sets? Okay, here sets are the fundamental idea in the study of mathematics. Okay, basically sets are the fundamental means it include all the, or else it is very necessary to study. Okay, sets are a fundamental idea in the study of mathematics and statistics, but they have a wide range of application in our daily life. Sets are commonly used to represent, gather, and analyzing the data that is comparable. Here in this sets, we have to take the data and comparable. In today's world, data is extremely crucial. Data is at the heart of every change that occurs today. Okay, here data is very necessary for studying common to general or specific, and so many things we have to study. That's why set is very important to study the data in detail with comparing units. Next, one can also wonder why set theory is so essential, because sets are significant. They more formally encode a totality of information on a specific type, because it has the information of specific type. It gives so many informations within a special characters. Set theory is concerned with the invariance of sets. It means information regarding what is in the set is not as much about set theory as it is about other areas of mathematics. So many applications are there in our daily life. Okay, that's why we have to study the sets. Now we have to define what is the sets and have to observe so many examples and also solve some mathematical problems in this chapter. Okay, basically sets. Okay, the definition of sets is a set is a well defined collection of objects. Okay, here the word that is well defined, the word well defined, it has meaning. Well defined means everyone should obey the concept. Means in generally it is a standard collection. Means everybody should obey this one. That is, set is a well defined collection of object. Whatever we have to collecting the object, that collection of object should be a well defined. Means everyone should obey the collection of objects. Okay, now let us discuss some examples. That is the set of all natural numbers. We know that the numbers. Natural numbers means the number starts with 1. 1, 2, 3, 4, 5, 6, 7, 8, 9 up to infinity. These natural number means the numbers always starts with 1, 2, 3, 4, 5, 6, 7 up to so on. It means have to be well defined. Everyone should obey this one. Okay. Natural number means must and should the number starts with 1 only. Then Z, the set of all integers, means the collection of all the integers. We know that the integers, the numbers of integers containing 0 plus or minus 1 plus or minus 2 plus or minus 3 up to so on for infinity. The numbers containing from 0 plus or minus 1, it means negative as well as positive numbers, that is called as a integers. The integers are also well defined, the collection of the well defined numbers. The set of all the rational numbers. Rational number means the numbers can be written in the form of P by Q, but Q not equals to 0. These type of the numbers are called as a rational numbers. We can collect all the rational numbers. That rational number should be a well defined. Means everyone should obey. Here, the set of real numbers. Real numbers means it include all the numbers. It may be natural, it may be whole number, it may be integer, it may be fractions, whatever. All the numbers are included here. The numbers are called as a real numbers. It is also well defined. And Z plus the set of positive integer. Z means the set of all integer. Here Z plus represents the set of positive integers. Okay. Here all the integer means it includes both positive as well as negative. Here they given only positive means this is also well defined sets. Then the set of positive rational numbers. It means all rational numbers means sets. Then we have to say positive rational numbers are also sets. Then R plus the set of all positive real numbers. All the sets are well defined collection of the numbers. Okay. These are the example for the sets. Now next move on the concept, that is, the following points may be noted here while writing or while reading the sets or else the collection of objects in this manner. Some of the points may be noted here. That is, the first point is objects, elements, and members of the sets are synonyms. It means the objects. Okay, the objects, elements, and members. All the words are similar. Sometimes it may called as a object, sometimes it may called as a elements, sometimes it called it as a members based on the examples. While taking the example, based on the example, we can segregate objects, elements, members, but all are the synonyms, means similar meaning words. The all these gives a similar meaning or same meaning. Next, second one point. Sets are usually denoted by capital letters. Okay, usually the sets are denoted by the capital letters like A, B, C, X, Y, Z, etc. Okay, next, third point. The elements of sets are represented by the small letters. It means, for example, I can return one sets here according to the point. Usually capital letter represents the sets and all the elements are written in the flower bracket. In between all the well-defined collection of objects can be written in a within the closed brace. Okay. we can write all the elements within the closed brace in a small letters. That is A, B, C, D, E. Okay. This is the representation of the sets. Okay. Here capital A represents the sets. It is denoted by set. Small letter A, B, C, D, E are written or shows the elements or objects or else members of the given set A. Okay. Now let us move on the next concept. That is, if A is an element of set A. Usually here I can take set A is equal to A comma B comma C. Okay. Here capital A represents the set and small letter A, B, C are the represents the elements. Okay. Here, if A is an element of set A, it means in the set A, the elements are A, B, C are present. Okay. These are the elements which are present in that set. If A is present, then we can say it as A belongs to small letter A belongs to capital A. Here, small letter A belongs to capital letter A means, so here small letter A usually represents the elements and which is present in set A. Capital A means set A. We can write the Greek symbol belongs. It means usually element A belongs to set A. What is the meaning here? An element A which is belongs to capital A set. Okay, that is A belongs to A. Usually the represent says A belongs to A. If some of the element, for example, here there is no element of D here. Okay, that time the element D which is not belongs to the symbol. Here this one represents belong. The line, another one line I can take on that belongs. It represents not belong. The element D is not belongs to set A. This is the representation of the belongs and not belongs to that set. Okay. Then usually the sets are can be represented in two types, or else we can say there are two methods for representing a sets. Okay. One is roster or tabular form. Another one is set builder form. Okay. We can study now one by one. First one is roster or tabular form. What do you mean by the roster form? That is, all the elements of set A are listed. The elements are being separated by the commas are enclosed within the brace. Means usually all the elements are of the sets are listed. Okay, we have to make a list of the elements. The elements are being separated by the commas. We can separate the elements by comma and are written within the braces. Means usually capital A. Okay, usually capital A, the elements are written within the brace and all the elements are listed. For example, A, B, C and D. Here A is an element, B is an element, C is an element and also the last one D is also an element. Usually in between the elements we have to separate the elements by the comma. These type of the representation can be said roster form. These type of the representation can called be roster form. Okay, we can study some example. For example, the set of all even positive integer less than 7. We know that the set of all even positive numbers means maybe the integer, mainly the integer containing 0 plus minus as well as, okay, the set of all even positive integer. What are those? 2, 4, 6, 8, 10, up to so on. But in the question, positive integer less than 7. Less than 7 means only 2, 4, 6. Only 2, 4, 6, 7 in a roster form. That is, usually in roster form, we have to write the elements within the brace. Here there is a brace and the elements are 2, 4, 6. So 2, 4, 6. I can also separate it by using the comma. This is the representation of the roster form of the set. Okay. Next example here. The set of all the natural numbers which is divided by 42. Okay. All the natural numbers divided by 42 means the number 42 is taken from the all the multiplication table from 1 to 42. Okay. Here the divide 42 means 1 is also divided by 42, 2 is also divided by 42, 3, 6, 7, 14, 21 and 42. All the elements from 1 to 42 are divided by 42. These are the representation of the roster form. The set of all the vowels. We already know that the vowels in English alphabet, that is A, E, I, O, U. We can write all the elements A, E, I, O, U within the brace. Okay, within the brace and also adding comma in between the elements. This is the representation. And also the set of odd natural numbers is represented by 1, 3, 5 up to so on for infinity. Okay, these are the example for roster form. Okay, now we can move on the next concept, that is the second one is set builder form. How can written in set builder form? That is, all the elements of sets possess a single common property. Okay, we have to mention in a set builder form, we have to mention the common property for the all the elements which is not possessed by any element outside the set. It means have to possess the single common property for all those elements for representation. Okay. Now I can take example here, that is in the set A, E, I, O, U. Okay. While seeing the elements A, E, I, O, U, all the elements obeys the common property, means these are the elements are vowels of the English alphabet. Vowels in the vowels in the English alphabets. Okay. So this is the common property. The common property can be written. Okay. All the elements of the set possess a single common property. That is called as a set builder form. Here, all the elements possess a common property, namely, each of them is a vowel in the English alphabet, and no one other letters possess this property except A, E, I, O, U in the English alphabet, usually denoting this set by V. I can represent or denoted like this V. Here X means the common element. Okay, X means the common element. These column represents the such that X, such that X is a vowel in the English alphabet. This is the set builder form. Here X represents the element. That element should be a vowel in the English alphabet. Next, move on the example. Okay, here A, the set A is equal to X is a natural number and the natural number is lies between 3 and 10. Okay. You have to take the natural numbers list. Okay. 1, 2, 3, 4, 5, 6, 7 up to so on. The common property here for elements x is an number, x is a natural number such that the numbers taken in between 3 to 10. Okay, the numbers 4, 5, 6, 7, 8, 9, 10 up to so on. In between 3 and 10 means the elements are 4, 5, 6, 7, 8, 9. Okay, we have to make the common property for 4, 5, 6, 7, 8, 9 is natural number in between 3 and 10. Next one, second, x is a natural number which divides 42. Okay, here x is a natural numbers. It can divide the 42 are 1, 2, 3, 4, 6, 7, 12 and 14. Okay, next, y such that y is a vowel in the English alphabet. We know that here the group is represents the set of vowel numbers. What are the vowels in the English alphabet? That is A, I, O, U, A, I, O, U. Okay, these are the alphabet vowels in the English alphabet. Then Z is a odd natural number. We already know that odd natural numbers starts from 1, 3, 5 up to so. Okay, this is the representation. Here, the in a sentence form or for a single sentence form or a single property can be written in the set builder form. We have to make a list in a set builder. Okay, next examples. Okay, roster form is have to list. Write the solution of set of the equation x square plus x minus 2 is equal to 0. The equation, the given equation of the form of quadratic equation. The given equation of the form quadratic equation. So while solving the quadratic equation, we can get the two solutions. That two solutions are written in within the brace. Okay. While solving the quadratic equation, I can take here x squared plus x minus 2 is equal to 0. We can solve this quadratic equation in more than 3 ways. So I can use here, that is multiplication of any two number, we get minus 2. Then add or subtract those two numbers, get x value. Okay, here 2 means 2 into 1. Okay, minus 2. 2 into 1. Here it may be plus 1. So I can balance here. While adding or subtract 2 minus 1 or 2 plus 1, we get plus x. So I can take plus 2 minus 1 because 2 minus 1 is 1. Again 2 into minus 1 is minus 2. The quadratic equation should be balanced here. So I can solving the equation x square plus 2x minus x minus 2 is equal to 0. Have to make the two groups x square plus 2x. In between this equation I can take x as a common, x plus 2, taking minus from these two numbers, it is x plus 2 is equal to 0. So I have to make the grouping x plus 2 is common to both sides. So I can take once x plus 2, x minus 1 is equal to 0. While equating these two to 0, it is x plus 2 is equal to 0, x minus 1 is equal to 0. Okay. Now, the solution of the equation x is equal to taking plus 2 on right side, it becomes minus 2. Taking minus 1 from the left side to right side, it becomes plus. Okay. The solutions of the equation. The solutions are x is equal to plus 1 or minus 2. So we have to make this, or we have to write in a roster form. It is A is equal to the elements 1 and minus 2 can return within the trace. This is the solution of the given examples, or else it is the roster form of the given equation. Now let us move on the second example. Now write the set. So the common property x such that x is a positive integer. The common property is have to take the positive integer and x square is less than 40. So first I can take x, after that x square. Positive integer. Integer means the number starts with 0, plus or minus 1, plus or minus 2, up to so on. Okay. Now I can take this one. The positive integer must be a positive number. 0 is not a positive number, or else it is not a negative number. Now I can take positive integer x is equal to 1. Then x square should be 1 square is 1. Next I can take positive integer 2. 2 square is 4. I can take 3. 3 square is 9. Next 4. 4 square is 16. 5. 5 square is 25. 6. 6 square is 36. 7. 7 square is 49. This is enough for solving this type of problems. Because here x is a positive integer. I can take so many positive integer up to so on infinity. The x square values 1, 4, 9, 16, 25, 36, 49 up to so on. Okay. Here the one condition should be x is a positive number. Yes. And another condition is x square is always less than 40. The element x square is less than 40. Here 1 is less than 40, 4, 9, 16, 25, 36. All the numbers less than 46. But for 7 or 7 square should be 9. So this from this number not included here. So we have to, the x is the common property. The positive integers are, here I can take set as a within the brace. The numbers 1, 2, 3, 4, 5, 6. Okay. We can take any these 6 numbers only. Then the result is correct. Now let us move on the example number 3. Write the set 1, 4, 9, 16, 25 in a set builder form. Okay. Here they given in a roster form. Okay. They given in a roster form. We have to make the set builder form. Set builder form means there is a common property. Okay. There is a common property for all the elements. So I can take 1, 4, 9, 16, 20. While solving the example 2, we know all the numbers here 1, 4, 9, 16, 25 are the squares of the x. Okay. So I can take the common property. Set A is equal to flower bracket x be an element. I don't know the element. So x is a, here based on the property I can take x is a squares. X is a squares of the numbers. Okay, here x usually denoted by x is a squares of the number. These are the squares of the given number. 1, 4, 9, 16, 25 are the squares of the given number. Now let us move on the next example. Example number 4. Okay, now I can read this question. Write the set 1 by 2, 2 by 3, 3 by 4, 4 by 5, 5 by 6. Okay, so based on the common property, I can write here because they have given set builder form. First, I can take A here. While seeing the numbers, okay, while seeing the numbers, there is a common property here. Here there is a 1. In a numerator containing 1, denominator is 1 plus 1 means 2. Here numerator is 2, then it becomes 1. Okay, then the common property here. Okay, the common property here x such that x is equal to n divided by n plus 1, because I can take 1 as a n, then 1 plus 1, it becomes 2. So I can take n is 2, 2 plus 1, 3. The single property is x such that n divided by n plus 1, where n is the natural number. Where n is a natural number, because the numbers are starts with 1. The numbers are starts with 1, that is natural numbers. Okay, this is the example number 4. Next, example number 5. Match each of the sets on the left described in the roster form with the same set on the right described in a set builder form. So they can given on left side. Okay, these left side represents the roster form and the right side represents the set builder form. We have to match the roster form to the set builder form. Here, principal, P-R-I-N-C-A-L, the word. Okay, this one should be option number D. P-R-I-N-C-A-L. These are the common property here x, such that x is a letter of the word principal. X is the letter of the word principal. Then second one, the set containing 0. The set containing 0 means the option number C is correct, because x is an integer. Then we have to find the value of x while taking plus 1 on this side, it becomes minus 1 minus 1 should be 0. Therefore, x value should be 0. The representation is 0. 1, 3, 1, 2, 3, 6, 9, 18. Okay. While observing the multiple choice question, the answers also should given in that question paper only. Okay. Here 1, 2, 3, 6, 9, 8 are the divisor x, such that x is a positive divisor of 18. Okay. I can take written here. Then last 3 minus 3. Okay. Here this is also written x is an integer x square. Here not x2 it is x square minus 9 is equal to 0. Up to this much, I engage definition, examples, and types of the written forms of these sets and also some examples. Up to this much, I completed here in this session. After that, I will discuss all the exercise problems in next session. Okay. If you really like my channel, please go and subscribe and also share to those your friends. Okay. More share and more like it may help for me. Okay. Thank you everyone. Please, if you really like my channel, like, share and comment to my classes. Thank you everyone.